Okay, so I hope it is started. Hey guys, welcome to the channel. And yeah, so it's detailed day 12 of DSA learning, and we have made pretty much uh, progress. And yeah, so I think the light is little less or what. My face is looking like little darker. Maybe let me add more light to my face so that I'll look more beautiful. I mean handsome. Sorry, just kidding. And yeah, we can jump to the topic. So yesterday I was able to solve one problem only. Okay. So just checking whether stream is working or not. Okay, so that's all. Let me close everything and we can jump to the problem solving. I'm thinking to maybe tomorrow or day after tomorrow I'm planning to cover 50 SQL problems in 2 streams or 1 stream. I'm just assuming how much time will it take. So I'm just planning to cover up SQL so that it will brush up my SQL skill as well. Yeah, though I can solve the problems of SQL, but sometimes it's like you don't know what interviewer is going to ask. So it's always great to uh, be prepared for the what I'm saying. Yeah, so always be prepared for the uh, unprecedented situations so that you can confidently tackle them if you have practiced before. So let me jump to the take you forward and hope my screen is visible. Actually, I did not set up the let me do one more thing. I need to connect QuickTime Player with my new movie recording. Yeah, so it's okay. Now we made pretty much progress, we'll say. So let's jump to the which side. We are learning arrays and we are in the hard section of the problem solving. So longest consecutive sequence in an array, we have solved it. Longest subarray with given some k positive. Longest sequence with given some k positive. So it could the sum will be positive. Okay, I always get scared of these problems where we need to solve some longest subsequence, longest sequence, and all. I always feel like these are the problems where I'll get stuck and I won't be able to solve them. So I need to combat the fear, and for that I need to practice a lot. Then only I'll be able to solve. So I have to work around it. I mean I don't know why this cursor is getting enlarged. I like it. Yeah, so that's why I'm planning to practice more on it. So we were solving this problem, longest subarray with given sum. Okay, let me close it. And so actually I was trying to solve it, but somehow I was not able to get the solution of it. So today I'm just planning to take the help of and after that I said like I'll check it in tomorrow morning, but uh, I did not get time. I won't say it because that's a kind of excuse that most of the time people give. So actually I just avoided. Maybe that will be pretty honest answer. I was like I was trying to explore multiple things, and because of that I did not uh, focus on this part. I thought maybe once I'll stream, then only I'll try to figure out the solution, or maybe I'll watch the tutorial. So that's why our tutorial, you can say our tutorial, both have anything will work for me. So okay, let me just recall the problem. So it was a problem like you have given an array that contains positive and negative numbers, and now we just want to and you have given a target sum, and you need to find a sub array, longest sub array basically, to be precise, and the sum of that sub array should be the given target sum. So first I thought maybe let me do one thing. I'll start scanning from the first number and I'll keep on adding until it will want the number that we are looking for. And if the number is not meeting, or if it is like it's increasing as compared to the number that we are looking, then we'll start dropping the weight, you can say, or numbers from the end. But the problem with this is like here we have not only positive numbers. If there are positive numbers, then that algorithm will work, but if you have positive and negative numbers, then definitely you will fail, this algorithm will fail. So that for that, like I was thinking what is the another option, but I wasn't able to you can say derive any algorithm. Then I just took the help of the, maybe you can say, hint. And after that I thought, okay, so we can create a hash map, and there we will store these values, you can say, will prefix you can say. So we will start from the first number and we'll keep on adding the next number, and then we'll store. And after that, like when we are storing, at the time we can check if something is matching with the target, then we can store it. Like this can be a potential, you can say that this is a one target that is meeting the criteria, so we can store the max value. And after that we start, you can say, start index from one index to till the another index, and then we'll check if we can get the number, and then we can perform a lookup. There will be order of 1, and in this way we can achieve it. But somehow when I wrote the algorithm, it is not working. So that's why I'm a little worried about it, and I'm not sure what is wrong with it. So that's why maybe I'll let me check one more time, because it's a new day and I might get solution. Okay, so I'm assuming if the approach is correct, so desperately I might have made some mistakes that I wasn't able to, you can say, figure out at the figure out yesterday, but might, if I'll see it today, so it's new beginning, so we can say I might figure out the solution. So yeah, let's jump to the solution what I made, and let me see if there is any problem that can be solved. If there is any problem, so we have current sum, that is 0, if you see my screen, and we have h. Okay, so first thing is we have numbers. Okay, we have numbers like 10 and 5, 2, 7, 1 and 9. Okay, so for positive number it is okay, but for negative numbers it wasn't working. So yep, so it is -3, you can say. I think I had one more example that was big number, so it was very difficult to get that number k equals to 15. So okay, so these won't help us in finding the solution. So can I say, first we'll create a prefix sum. So we'll be having prefix sum, and we'll store everything in a hash map. Hash map will store everything, and then while we are storing the values in the hash map, we can say if the prefix sum is matching with the target, then we can we say like this can be potential, and will all the prefix sum that are matching the target can be the longest subarray. So we'll just keep on updating if prefix sum is matching with the you can say. So while I'm creating hash map and all, at the time we can store it. After that we'll start from the first number. Okay, and we'll see. So maybe let's say this number, and we'll see if we are dropping this number, so can we get the, are we getting the, you can say. Okay, so suppose I'm dropping this number. Okay, so we know we have different prefix sum. Okay, so we have different prefix sum, and we need to check, can it be game changer? I mean, you can say we need to scan all the elements. I mean, you need to check if anything is matching. So we have this number. Okay, I think we can get it or what. So first let me say count equals to 0 if we are just adding the key to current sum, so that is nothing but the sum of plus element existing element. So this is the value and we are just storing it, we can say we are appending it, and I don't think we need prefixum because that is not necessary. And now just I'm looking for one thing. Key. Key minus 10. Really? If we are dropping 10, you can say, then okay, if anything, so what will be the value of so if it is key is 15 and we just, so we need 15 somewhere, it should be, so key could be 15. Okay, 15 equals to you can say ps prefixum plus x. So prefixum 15 minus ps equals to x. Wow, will it work? I believe so. But how are we going to calculate the prefixum? For that you do not need to store the prefixum every time. Let me do one thing. I'm thinking of something and let me, if it will work. I mean, yeah. So first let me say it like this. So what we will do, first we'll store, you can say step 1 will be, let me write down the algorithms and then we'll see if it is working. I'm not sure because now I'm little worried, or you can say not worried, bro. What are you sometimes your words are very ugly and uh, it feels like you are less confident of what, and we are here to build confidence and learn the problems with hustle and tussle. Okay, so step 1, what I'm thinking, first calculate prefixum. Okay, and store it in you can say hash map. Great. So as how it's going to store, it will be prefixum and corresponding index. So that's just going to be stored. Step 2, start iterating at that time. Okay, let me add one more condition. If something matches with target, okay, then store it in max, store it in count. I mean whatever the max will come in the row. Step 2 will be start iterating through the array, and we'll do two things. Calculate prefixum, so prefixum, and suppose we are at the index, you can say index I, okay, and we have prefixum ps. Okay, we are at index I and we have prefixum ps. So that means till so far we got the ps value, and now we are looking for something that can, if we remove this part, ps drop, and can we get somewhere maybe this is the remaining part array and this is the part that we are looking for. And can we get some value, and if we are adding up this will come as target. Okay, so can I say what we are looking for? So we are not storing some part of it, like we are storing the continuous value. So we have this value, this is ps, and this is nothing but, let's say, x. So ps plus x will be nothing but target. No. Okay, so here ps, so this is our value of that we stored in the map. So you can say ps plus target is nothing but equals to x. So what will be the value of target, not target? So we are looking for something that can change to ps plus target. Hey, what I did? Yeah, so if something is ps plus target is nothing but something is matching this criteria, that means we can say, yeah, we have value, and then we can calculate the value. So the index that we are at right now, so before it, like till this we are just dropping the values. So you can say suppose it is k, so k minus I, so we are dropping, and so this will be the value. And k, suppose it's 5, it is 2, so 5 minus 2, and suppose it is 0, we are just dropping 5 0, that means 5 minus 0 is 5, so 5 element will be there. First thing, let me do one thing, ps, and if you can say cnt, if k equals to cohesive, that means it could be, so count is equals to max of count, and here we have, sorry, my bad, c is current sum. No, you can't say it. Count will be count, and we have this number. So can I say till so far, if the k value is matching, then idx plus 1. So yeah, that's all about it, and now we have to start. So we do not need to look for this one. Now we are just going to enumerate prefixum. I was using prefixum, we do not need this. We are going to iterate through all the elements again. So let me say rdx enumerate, you can say nums, yeah, nums we have na, yeah, sorry, I used Hindi word, nums. And so we are starting from 0. Key will be, we are looking for ps, so if something ps we have, you can say prefixum, let's say cs equals to 0. My bad, I need to change the location. If you are using Python, indentation is very important, so keep that in mind. I hope if you are solving these problems, it's a cup of cake for you, or it's piece of cake. You are already aware of all these things, I'm assuming. And if you have learned Python, and if you are solving the problems, then definitely you are aware of it. So it's a beginner, or you can say if you just started, then it is a problem for you. I mean, just at that time you have to consider, if especially if you are switching from any other programming language. Here everything is controlled by indentation only. So indentation is the key factor here. But that will come into your bloodstream once you will start learning it. So yeah, okay. So I'm just looking for key, what we need, what needs to be here. So we know cs prefixum will be cs plus equals to el, so that will be the prefixum. So far we have this prefixum, and we want to drop it, because for example if we are getting first element, then we want to drop that first element. So okay, yeah, so can I say like if we are dropping first element, can we get anything from the array? Yeah, if anything is matching till so far. So now key will be prefixum, or no, yeah, cs current sum. So we need to delete this value, or you can say we need to subtract this value. So key will be, we have target value, that is k, and k minus cs, no, keep k, we are looking for a value that will match the criteria. Okay, so k plus cs will be the value that we are looking for, and k plus cs if key, that means we have current sum, and if we are dropping and if we are adding k to it, it will be the key. So okay, great. Now if key in hm, that means hash map, then max will be count, existing count, and hm of key minus idx, let me say idx, because here fishing, okay, so we are getting this number. Let me see if we are able to solve it, or still we are getting issue. Last time I failed it. Why it is taking time? Did I make any mistake or what? Or it's taking time? What's wrong with it, bro? Let me use test case and try. Okay, I think now we can solve it. It will be passed. Hey, great. Finally we solved it. It's still processing, but yeah, finally congratulations to you and me, both of us. So finally we solved it without the help of, without watching tutorial. And also sometimes that's why I already told you, and this time again I'm telling you. So sometimes restart is okay. And yeah, for example, if your laptop is not working properly, it is, you are facing lag, or there are some, and if you start it, sometimes if you feel like your phone is not working properly, then if you restart it, it starts working. So that's how life happens. If sometimes you need to take rest, if something is not working, or you are feeling worried or and all, then just take rest and start it again tomorrow, maybe after taking rest. And it will be, sometimes you will feel like, if you are feeling overwhelmed or because of trying multiple times a problem and or something, then definitely go for this. Okay, 1 minute. Did I solve some different problem or what? I think we already solved this, bro. Just very just thinking what I did. Submissions. I think this one is the problem where I need to check. So let's jump to the another problem, and I don't think we submitted it recently. Oh, both are linked or what? Laws. K positive and longest subarray with some K. I think we solved both, bro. What's wrong with it? Yeah. So irrespective of whether it's positive, then it's very easy. it will be cup of cake for you. So now we can solve these two problems, and if you see there is a hard problem. So let's jump to the another problem. Count sub-arrays with given sum. Okay, count sub-arrays with given sum. So now we need to count all the sub-arrays with given sum. Okay, let's see. Given an array of integer nums and an integer k, return the total number of subarrays whose sum equals to k. Input 1 1 1 1, k equals to 2. Explanation: in the given array 1 1 1 there are two subarrays 1 1 and 1 1. So we can see the numbers can be positive and negative. So I think just we need to make a little tweak in this the existing problem, and we will get to know all the you can say all the solutions. Yes, we can say all this, we will get all the solutions. So first thing is like we are going to check with existing problem, existing array, and what are the different solutions. Then at the end we just need to check all the elements in the hash map. So what I am going to do, we'll use same algorithm. So I think we can solve it quickly, but let me still assign it 20 minutes of time. I'm assuming if I get some sort of you can say sometimes I under evaluate some problems and I feel like, oh, this is also the solution, this is also the challenge here, and also I don't know 1 1 1, and you know this problem contains negative numbers similar to the 1. So I think just it's extension of the first one. Instead of they like we were just looking for max there, and here just we need to check for all the counts that we are getting, and where we are it is meeting the target. So and we know whatever we are calculating. So let's jump to the problem solution only. I think we do not need to explain it again. So let me go to the solution. So first let's calculate perfection. Okay, so let's see, cs equals to 0, current sum equals to 0, count equals to 0. So this will be the count, and here we do not need to check different length of maximum, and so it's total count you can say. So okay, let me say TCN total count, and we have 0 right now. And now we need to check perfection, es equals to 0. Do we need this current sum? Okay, no need. So for let me start hash map as well. Hash map will be nothing but dictionary in Python. So dict, let's just initialize it, and now let's start calculating the you can say let's start building the hash map. So for that let's for index. Okay, so we are going to use nowadays I'm using enumerate too frequently. I don't know, sometimes yeah, that's why enumerate okay, and here we have nums. So yeah, great. We'll start with 0, index 0, that is a regular process. And now we are just going to cs is nothing but cs plus equals to, and it will be the value of the last element, or you can say the processing element. And yeah, so we stored the current sum, and yeah, or you can say we updated the current sum prefix sum. That's totally that's very accurate, or you can say more accurate word should be used here. Okay, so we have current sum, and now we need to store it in the hash map. And what value will be? So it will be the key. So you can say hash map of current sum will be storing the index of it, like where it is the exact value is happening, or you can say what is the index where we got this you can say prefix sum. So okay, so far we got we have built this, and let's simultaneously we need to check the total count. So if you can say if the current sum is meeting the criteria of cs equals to k, that means this can be, not can be, this is one solution of it. And yeah, definitely, and we do not need to check overlapping problems or you can say overlapping solutions, because everything is separate here. whenever we are going to calculate. For example, if we are going to uh, large the window of, then that means we are getting new solution, the length will be changing. Okay, so there won't be problem of that kind of problem won't, we do not need to consider like whether these are the same solutions or what. So we can you can blindly you can write down the solution. So cs equals to k, that means the value of prefixum, or the sum that we are getting so far is matching with the target sum. So can I say, if it is the criteria, then that means simply we can store it, or we can upgrade, or we can advance, not advance, that will be a wrong word here, we are not advancing index and all. So here simply we can you can say update, or you can say increment the count. So total count will be plus equals to 1, that will be okay. Here we just need to check the count, we do not need to check the total, so we just need total number of sub arrays. Here we do not need to calculate or consider anything. So yeah, that's a great thing. Okay, so it is now we just calculated the prefixum and we stored it, and also we checked like if these criteria are matching, because we are going to check and we are going to reduce the numbers from behind the scene or from back side. So now we need to check for that one. So let me start again, idx and el. Okay, we do not need even idx here. Do we need it or not? Yeah, we do not need. So now even we can reduce or remove the idx, but let's keep it as it is. So now let me say el in enumerate nums. Okay, great. So we are getting not even, we do not need nums. So far we got this value, and I think we can optimize it. We do not need to use enumerate. Okay, but let's leave it for the time being. And so we have element, and now we need to check. So we can say cs, let me start again, cs equals to 0. So cs will be plus equals to el. So we got the we started calculating prefixum. And okay, so key will be, let's calculate key will be k plus cs. Okay, cs will be the value, and k, if we are adding, is there any key matching this criteria? If you can say key in hm hash map, then that means this value is matching, and we can say t total tcn plus equals to 1. Okay, great. Now this is the one solution for it, and so finally return tcn. Wow. So let's see if we can solve it. And yeah, last time I forgot to check the time complexity of it, and to be honest, oh, we got wrong answer. Great. Your output 13, we expected 8. What went wrong? So okay, let me see description. Are they looking for the in an array of integer nums and integer, return the total number of arrays, sub arrays whose sum equals to k? The given array 1 1 1, there are two sub arrays 1 1 and 1 1. Okay, but both are same. this is the case, I'm definitely going to. What's wrong with it? I think I'm gonna. This will be some. Okay. Shall I begin it with? No, bro. It will be time taking if I'll start with it. It's 5 greater than the. Shall I print them? Okay, let me see. Okay, I'll do one thing. Let me create a function that is going to print the solutions. So I'll check it. Define. So print solution self, and you can say start and end. Print nums of end. Let me say nums as well. Okay, so here, so far we got it this index. So we have this number of cs equals to k. That means we have okay. So print, we can say self dot print solution nums, and start will be nothing but the 0, and end will be nothing but the idx. So here we are going to store end will be idx. Okay, but when we are calculating this, let me add index as well. So this one. Now let me enumerate it. So okay, we need to debug it, bro. I do not know. I'm not gonna solve it like all the dry run, because the number is large. If we have a smaller number, I can check it. So now see, we just passed 0 test cases. Okay, that's cool. So idx el in enumerate. I don't know, I feel like since yesterday I'm feeling like something is stuck in my throat, maybe here, I'm not sure. It's feeling like something is sticking in my throat. It is disturbing, but leave it. It will go out. I mean, it will fix it. Will fix it automatically. It will fix automatically. Okay. KFC key in HM. Then that means we need to find out the index of key. So you can say idx is nothing but t idx, let's say, and will be hm of key. Okay. So target index we can say, and we have index as well. So index we are removing, and after that whatever we are getting the value there, so you can say just we need to drop that index. So if there is at one index, that means we are dropping 2 elements. So 5 minus 1. Am I doing something wrong? It's 0. So we are at 4th index. 4th means there are 5 elements. 5 means we are removing 1. 5 minus 1, 4. So yeah, it will work. So we need to just do one thing. So we have this, we have index, and now can I say self dot. Okay, it's great. I'll copy it. No need to write it again. Okay. Oh yeah. So start will be nothing but the idx. You can say idx. Okay, and t idx. But you know, if we are removing this, that means we are getting from 1. So till t idx. Okay, now I think it's great. Let me see. If we are getting all the solutions, then it's great. We can check it. Now what's your problem, bro? Where is Nus? Hey bro, nums and literally. Let's see what are the solutions. 1 1 comma 1 comma 1. Okay, great. Now second 3. We have 3. We are looking for 3. So 1 2 3 and 3. So we got two solutions. Here if you see 13. Okay, we are getting blanks as well. Ah, got it. Bro, so what is the solution for if target is 0? Okay, so at least when I'm debugging I forgot to mention it, or maybe I forgot to consider that corner case, and that's why sometimes debugging helps us to find out the corner cases. Do logically I should think about it, like could be the worst case here, and I did not thought about it. And here if you see the problem arrives, and yeah, so we are storing cs equals to 0. So can I say if the index start and end index has one value, then it is the solution? Okay, so let me say it. This, though it is hacky approach, but if we will not consider, then 22415 x 7 will be there, bro. That is also unfair. Some sort of mission page I'm seeing. So here we'll get the correct answer. If cs plus 0 EL equals to this, then only we are going to calculate it. And yeah, every time we are adding element. But here if we are talking about, so here the problem will arrive. Three, 2, 5, 1, 6. There are 8 total solutions, right? And I'm missing corner case, bro. And here my logical skill will be tested. If I'm able to come up with solution, that means you are logically fit, otherwise you need to practice more. So IDXCL in not there. Let me work on it. Let me think about it. Think out loud. Okay. So there will be. So when we can consider an element is 0. So if you notice, when we are calculating prefixum, at that time what we are doing, we are checking if an element when we are adding, is it meeting the criteria. So first we'll start with 0, then it is matching the criteria. So CS will be CS plus equals to 0, so that is okay. Then we added another element and we are checking at it. So this is okay, we can see. But when we started checking, again using hash map. So what is the problem, bro, here? Just let me know. I don't think there is problem. If you talk about it, maybe let me see it. So okay, if you see, first we started with drop first element and C. So we did that. Then second, first plus second plus third, and so on. So what is wrong here? And I'm not getting. Let me see. I think I'm printing incorrect way, or what? Let me add the time. So we have 12:46 right now, and I'm just planning to finish it quickly. Okay. So you can say the first solution will be not here, and we are adding CS. So first when we will add first element, that will be 0, and when we are adding 0, it will be CS plus equals to 0 and CS equals to K. So yeah, so can we say, so total count will be plus equals to 1, and self dot print solution nums and 0. You can say starting from first index and till the index. Okay, index will be 0, so we'll go from 0 to 1. Nums start to end, and end is pointing to index. Index will be start to end plus 1, means. So where is the problem, bro? Let me just close it and let's see what is happening here. Your output none. output 0, but we are getting 0 logs. That is where I'm worried about it. CS equals to k. Okay. I forgot it. Print solution CS plus element. Okay, sorry. CS plus equals to element. We added just element, and we are saying current sum. So it's prefix sum, you can say, and key is nothing but k plus CS. Okay. K plus CS. If it is matching, that means if we have whatever we have, and if we are adding k, that means it is matching the k. If key in hm tidx, that means that current index will be the key, and tcn plus equals to 1, and self index plus 1. Print okay rdx plus 1 and tidx. What is some pieces missing? I mean, literally, what I'm missing here. I'm missing making weird faces, but I don't know. Sometimes I feel like what's wrong with me. Tcn plus equals to 1. Total count plus equals to 1. Okay. Zero. Element just we added, that means we need to drop that element. key will be k plus cs. Current sum plus key is k, it will be key. What if there are more than one key? Then definitely it will be producing wrong result, right? How to tackle that? Okay. Then one. Okay. If we are adding key, there will be only one key, right? If we have more than one key, no. Sum of sub-array ending in the index I is simply the sum of all the elements up to that index. I mean, I've missed something or what? Instead of directly searching for sub-array with some k, first declare a map to store the prefixum and their counts. Prefixum. Oh, we are adding counts. Honestly, from index 0 to n minus 1, where n is the size of array for each index I, we will add the current element array of I to this prefixum. Calculate the required prefixum x minus k, add the count by 1. I mean, are you focusing on it or what? First, declare a map to store the prefixums and their counts. Initially set the value of 0 to 1 in map to handle cases where subarray equals to target sum k. Case cases, for example, if the array is 3 minus 3 1 1 1 and k is 3, at index 0 the prefixum is 3 which equals to k. Hey, hold on. What is the another approach? Okay, so it's not the approach that I'm looking for. I'm looking for optimal. Missing something. Instead of directly searching for subarray with some k, first declare the map to store the prefixum and their counts. Initially set the value of 0 to 1 in the map. Okay, value of 0 to 1 in the map to handle where a subarray equals to the target sum k. Add current element to the prefixum. So added sum to remove. Prefixum Hold on. Value to remove. Update the count of current prefixum in the map. First, let me do one thing. Let me see if we can resolve it. Missing. I need to. Bro, something is not right in my approach. Okay. Let me think about the approach that they are using. Okay, leave it. One thing will do. Let me exit. I feel like overwhelmed. I need to take pause for this one. But first, this is the first time I'm doing this. Bad habit. Bro, I have to solve it anyhow. Otherwise, I'll feel underconfident, or I'll feel not working. So I need to solve it anyhow, irrespective of how I'm going to solve it. Just let me think about it. Let me watch the video better.
So it's time to discuss the most optimal solution in the interview that we take.
It will take. I mean, it's better if I'll use.
So it's time to discuss the most optimal solution. The most optimal solution will be using the concept of prefix sum. So what is the concept of prefix sum? Let's understand that. So assume I say, I'll go till this particular element. And if I ask you, what is the summation of all the prefix elements? So basically 1 plus 2, 3 plus 3, 6 minus 3, 3, 4, 5, 6. So I can say the prefix summation is 6. And can I say the summation of these 3 elements is 3? I can say that the summation of these 3 elements are 3. And if I ask you, what is the sum of these elements, the remaining elements? Please do not add it up. Please do not add up single elements. I'm just asking you as a normal maths. If the total summation is 6, the most optimal solution. The most optimal solution will be using the concept of prefix sum.
So they have added some sort of.
The most optimal solution. The most optimal solution will be using the concept of prefix sum. So what is the concept of prefix sum? Let's understand that. So assume I say, I'll go till this particular element. And if I ask you, what is the summation of all the prefix elements? So basically 1 plus 2, 3 plus 3, 6 minus 3, 3, 4, 5, 6. So I can say the prefix summation is 6. And can I say the summation of these 3 elements is 3? I can say the summation of these 3 elements are 3. And if I ask you, what is the sum of these elements, the remaining elements? Please do not add it up. Please do not add up single elements. I'm just asking you as a normal maths. If the total summation is 6 and this one's sum is 3, how much will this be? 3, because this minus this will give you 3. And this is the concept that I'll be using. So what I'll try to look forward is, I know in a particular index, we will have a prefix sum as x assumed. And I know I'm looking for a subarray with sum k. So what is the remaining portion? What will be the sum of the remaining portion? Can I say it will be x minus k? I can, because if the prefix sum till here is x, and probably there is a subarray. Probably. Like over here there was a subarray. Over here there was a subarray. No? That's why the sum came as 3. What if there is a subarray whose sum is k? Then in the backward, there will always be a prefix sum. There will always be a prefix sum till here, which will have a summation of x minus k. Till here, the prefix sum will always be x minus k. Similarly, if I have to visualize it again, can I say this? If I just knock it off, can I say this? Till here, also the summation is 3. Thereby these 2 elements will also give you how much? 6 minus 3, which is 3. Agreed? What did you observe? You observed one thing. The total summation was 6. And I was looking for 3. I was looking for 3. Because we were looking for a subarray which ends at this index. We are looking for a subarray which ends at this index. And apparently over here, there was one which was ending over here. And there was other one which was ending over here. So if there are 2 subarrays which are ending at here with a summation of 3. If there are 2 subarrays which is ending at here with a summation of 3. Can I say there will be 2 subarrays? There will be 2 prefix sum of x minus k? I can. We had till here 3. We had till here 3. I can. Right? Because there was 2. So in the backward, there will also be 2. There will also be 2 with the same sum. So can I say if I'm looking for k over here, so instead of looking for k, because it's somewhere in the middle, I will look for prefix sum. How many are x minus k? How many are x minus k? Like in this case, let's again go back. Like in this case, what did we see? We had 3. But instead of looking for 3, if I just erase it off, and this is 3. So basically what I'm saying is, till here the prefix sum was 3, and till here the prefix sum was 3. So I know there was 6, and I was looking for 3. So in the backward, there was 2 elements with 3. There was 2 elements with 6 minus k. There were 2 sub prefix with 6 minus k. That means there will be 2 subarrays. One is this, and the other one is this. This is the reverse engineering. We just did the reverse engineering. What did we say? We said if till a point the prefix sum is s, and I am looking for k. So in order to figure out how many k are there, I will look out how many s minus k are there. How many s minus k? The number of s minus k will be equivalent to the number of k. Over here, 3, 1, 2. So equivalent. If you take this will be the other subarray. If you take this will be the other subarray. So I did look in the opposite direction. Why did I look in the opposite direction? Because we can easily store the prefix sum. We can easily store the prefix sum, but we cannot find out between sum. That's not possible. That is why. And I hope you kind of got the intention. In case you did not, do not worry about it. The moment I do the dry run, everything will get crystal clear. So let us quickly do a dry run on the algorithm. So what are the data structures that we require? So if you remember, till here we had a prefix sum as s, and we were looking for a subarray with sum k. So previously I was looking for if there is an occurrence of s minus k, if you remember properly. And that means we are looking for, was there a prefix sum? We were looking for, did it happen in the past? So what better than a hash map? So we will be using a data structure as hash map, which will be storing prefix sum, how many times it occurred, and that will be count. Why and everything you'll understand as we move forward in the dry run. And we will take 2 variables, one that keeps a track of what is the prefix sum, the other that keeps a track of the number of subarrays. So initially the prefix sum is 0. So please make sure you enter 0 as 1, saying is the prefix sum of 0 and count as 1. Why? Because initially when we started, we did not pick up anyone. We'll understand the significance of 0 as we move forward. So initially we will be standing at 1. So let's add it to the prefix sum as 1. So what are we saying? We have some elements that gives us a prefix sum of 1. So in that sum elements, we will look for a subarray that ends at this index with a summation of k. So there must be some previous elements which can be excluded who have a sum of s minus k. Agreed? Because if this is s, and if I'm looking for k, the excluded people should be s minus k, which is 1 minus 3, that is minus 2. Do we have a minus 2? Do we have any previous elements that gives you a prefix sum minus 2? No. So not possible. Next, take 1 and put it as 1, 1. So there is a prefix sum of 1 that occurs once. Perfect. Let's move ahead. So we have a 2. Now, if we have a 2, we add it to the prefix sum, saying we have a summation of 3. What are we saying? We are saying there are some elements which gives me a sum as 3. I'm looking for some elements which ends at this particular index who gives me a sum of k. So I need to exclude elements with a summation of s minus k. Then only I'll get k. So what is s3? What is k3? I need to exclude elements which gives me a summation of 0. That means no elements. That's why storing the 0 has significance. Got it? So the count will increase by 1 because there's what? Have a 2. We add it to the prefix sum, saying we have a summation of 3. What are we saying? We are saying there are some elements which gives me a sum as 3. I'm looking for some elements which ends at this particular index who gives me a sum of k. So I need to exclude elements with a summation of s minus k. Then only I'll get k. So what is s3? What is k3? I need to exclude elements which gives me a summation of 0. That means no elements. That's why storing the 0 has significance. Got it? So the count will increase by 1 because there's 1. So there can be one prefix sum which on removal will give me this one. So done. Next, please take 3 and put it over here. Let's move. We have a 3 again. Let's add it up. 6. So this time we have a summation of 6 and we are looking for k equal to 3. So we have to remove s minus k. We have to remove elements with sum of s minus k. So what is s? 6. What is k? So if you remove prefix sum 3, so that is, yeah, we got it. We got it once. That's very eminent because if you remove this, you'll just have this one. So this is why this works. Thereby, since 3 occurs once, the count will increase by 1 and 6 will go as 1. Perfect. Let's move ahead. The moment you move ahead, there's a minus 3. Take this minus 3, add it up. What do you get? 3. And if you're getting 3, this is the moment you start again looking forward. You're like, total 3. Looking for 3. How many exclude? Anyone who gives you a summation of 0. Exclude anyone who gives you a summation of 0. We just have 1, which on exclusion gives me a summation of 0, which is no one. Thereby, so there's...
I get it. But still, I'm thinking like, how can you, bro? Let me clear it out first. So, we have current sum, and let me set total count and HM dictionary. And let me clear this all. And yeah, so HM of 0 will be 1 because if there isn't anything. Now let me start from first element. So EL in you can say nums first element, and then let's see. Okay, so this is the element. So CS plus equals to element. So this is the total so far current sum, and now we are looking for k. That means if we are subtracting k from CS current sum, so we are looking for key if there is any CS minus k, then if we'll add k. Okay, so I mean So we have CS so far, and we need something K in this one. That means we need to find out if there is any current prefix sum in the past, that is K. You can say CS minus K. So CS minus K, if CS minus K in you can say, yeah, CS minus K in HM, then TCN is nothing but plus equals to, okay, you can say, this is, I'm again making mistake, so total count will be TCN will be nothing but HM of K CS minus K. Okay, this is the value, and finally we need to add this value, so you can say HM of CS plus K equals to plus equals to 1. Yeah, if it is for the first time, then if CS plus K, not if CS in HM, that means it is already then CS plus HM of CS plus equals to 1, else HM of CS equals to 1. Okay, so here we go, and finally return TCN. I think now it will work, but bro, I'm sometimes feeling like, what are you doing, bro? Things needs to be more practiced, as I am feeling like you are making the same mistakes again and again. You are making the same mistakes again and again, again and again. Okay, get it? So yeah, let's jump to the final solution, final problem of hard section, and we'll jump into expert again like tomorrow. So I need to practice it. So given an array of integers nums and an integer k, return the total number of subarrays whose OR equals to k. Integer nums and an integer k, return the total number of subarrays whose OR equals to k. Hey, it is very similar to the existing problem, but little different. You can say 4 and then 2 2 6 4, and another one is the k equals to 6. We need given another subarrays. Okay, and another one is the all are positive or what? Okay, we have positive numbers only here, so I think for Java only we need positive numbers, right? So the second number will be 5 6 7 8 and 9. I think it's similar to the old problem. So suppose, so we have a jar of all the numbers, nothing but A's or B's or C's or D. This is the jar of all the numbers. You can say A, B, C and D till here. And now I'm just looking for if something can give me value K. And let's say this is nothing but the value K. That means the numbers that we have added so far, we need to counter them, or we need to remove them, discard them. Oh my god. Okay, so we have let me jump to this. And so yeah, I mean literally my mic is out or it's discharged. So I don't know if my laptop voice is working or not. I think now it will work. Very okay. Let me put it on charging first. I don't think. Hello. Okay, so I don't know if it is working or not. Let me just continue. So we have the numbers, and now just I'm looking for something that can give me this value. So K. That means we need to, whatever the jar that we are getting so far here, we need to add it, not subtract it. So if we'll say like A jar B, and if we'll say jar, you can say A's or B's or C's or D, then A's or B will be finished and we'll get C's or D. Okay, so first thing I observed this one, and literally what are you doing, bro? I'm using so many times literally word, but here, so based on this I can say okay, we got this. But what if suppose I'm getting another C or D here and as well? Okay, everything will be positive, so you do not need to think about that. That 1 2, if these are the XOR, then this one will could be XOR. I think we do not need to use hash map. I mean here simply start A XOR B. Suppose this is the XOR, and we'll say if it is matching, if not matching. Okay, let's say we have numbers like A, B, C, D, E, F, G. Okay, now we just started. So first we have A. Before that we do not have anything. K could be 1 to 10 raised to 9, so 0 is not there. And what are the constraints for other numbers? They can be 1 from 1 to 10 raised to 9. Okay, so that means yeah, there won't be any corner case of 0 and all. So A or B is there. Let's say at starting we have A only. Now, okay, now we got A or B. So we'll see if it is matching. Okay, we can't say, right? Here we do not know when to drop the number. Okay, so we can't say like, yeah, if this is the value of this. I know. Yeah, we can't use like, now it's V A or B and it is increasing, so can I say, can I drop this one? So no, that's not the case. So we need to use hash map. Definitely we need to use hash map, and hash map of, we say, so far we got A or B. Initially prefix will be prefix jar will be A or B. Okay, okay, I'm confused. Okay, let me think more. A or B is the prefix till here. Now I need K. Minus something or should be, let's say, X, and it is returning K. A or B, XOR X. XOR X is nothing but K XOR X. Okay, so if A or B is equals to K XOR X, then we can say it is matching. So we need to find something that is equivalent to K XOR X. Hey bro, what are you doing? How can you say like, if we are taking jar here, it means it will be jar here? It's not mathematics, right? That's why. But wait. If something is like, if this is equals to this, then if I'll add something in this one and this one, then that will be, yeah. So here is B XOR X. XOR X will be K XOR X. So we can say this one will be counter of, both will become 0. So I mean, I can say A XOR, you go here, A XOR B is nothing but K XOR X. So can I get something from this number? I'm just thinking about it. Okay, so I mean, literally what needs to be done. So we have numbers. Okay, now we are at, suppose we are just calculating prefix jars so far here till here. So, and we got like A or B, and the count of it is 1. Now we can say whatever count we are getting here so far. Now can I say like, if I need to look for something, maybe if I can get the jar of it, maybe you can say here we are getting I need to get find take k. Okay, so we need I need to find k. That means so I need to add something k's, or you can say x will be a's or b. Okay, okay. Hmm. So far I can see we have a's or b. Okay, we have so far here we are, and now we are looking for k. So can we get, like, by just calculating some array, some elements from it, and the jar of them will be k. So that means we need to add something in the k, or we need to take jar with something and it will turn into a or b. So if I say k is or x is nothing but a or b, but how can I figure out like what will be the value of? Okay, so I'm assuming we have k's or x is nothing but a's or b. Okay, so if I need to calculate x, then it could be k's or k or x, nothing but a's or b's or k. Okay, that will be the case. Yes, perfect. If we are adding something here, then it should be here as well. So k's or k will be 0, then x will be nothing but a's or b or k. So basically we need to find out something. You can say we are looking for a's or b's or k in the prefix search. If it is matching, then whatever the count we are getting from that, we are going to say that will be the total count. It could be matching for first half, second half, and all. So can it be? Yeah, it could be. When so we got the solution. Now let me see. I just got the algorithm. So for x uh, prefix pxs is nothing but initially 0, prefix jawsum you can say, and let's start from I'm just confused about the corner case if I'll get something. I don't think we need to consider that condition. Suppose we are looking for a's or b, and so far we got a's or b. Focus, bro. You are losing your mind. Hash map will be nothing but I'm feeling like, how can I solve this? I got like, we need to look for x, a's or b's or k in the prefixum. So for example, if we are we are proceeding like this, and till here we got a's or b's or c, okay, and we need k, so we need somewhere like subarray with k. And so can I say like we need to find out something in the prefix that is a's or b's or c or k. So we can look for it into hash map. If there is any, that means whatever the counts that we are getting, that we can pull and we can add in TCN, total count, that is okay. But do we need to add any extra conditions where that will be to check? For example, there it was, am I losing my hair or what? Okay, so earlier I can see there was a gem of 0 equals to 1. So shall I say something like this? Do I need to add it? Not sure about it. That's why I need to figure it out. Like, do we need such a scenario or not? So I need some sort of solid example for it. So for example, zero means okay. What is the meaning of it? That means we are looking for 0 and sorry, my bad. I just sneezed on my laptop, iPad. Okay, I'm just confused about it. Like, where we need to add anything, or I just farted. Actually, my gut health is not good. That's why I'm feeling some sort of problems. Okay, so here I have A's or B's or C's or K, and I'm looking for if I need 0 somewhere, and I'm not sure, I'm not able to decide whether I need to add 0 and when that case will arrive. So maybe I need to check. Let's proceed without it. But how can you be sure? When can it be case? Suppose I have initially 5, okay, and now I just added 3, XOR 3, and now I'm looking for 5 XOR 3. It is something where some value, and that is matching the criteria. 5 XOR 3, that is our target. HM of 0 equals to 1. I'm not getting it, but let me add it. Okay, I feel like when we have something that is complete value, then for uh, nums nums, let's say in nums, and so the pxs so will be pxs is nothing but you can say pxs xor el. So for this is where the value that we have, and now we are looking for something that we can make it. So if let's say key is nothing but pxs that we got right now xor k. So if we have if key in hm, then you can say total count tcn equals to 0. So total count will be tcn plus equals to hm of key, else and finally we need to add this value into the our hash map. So if pxs in hm, then that means hm of pxs means primary you can say prefix JAWSUM is nothing but will be it will be plus equals to that we got one more count, and else you can say hm of pxs will be equals to 1, and finally let under tcn. I'm just assuming blindly, but I have to make change into my habit or what. Okay, so we solved it, and just let me see your tutorial. What if I'll remove this? Will I get the solution? No, right? Okay, so we got it, and the time complexity for it will be order of n log n. So log n for lookup in the map, and order of n, you can say every time we are traversing each element, and after that we are looking into the map. So for looking into if we are looking for a key into map, then it will take order of the log n. So total will be n times and log n at each query. So you can say n log n will be the time complexity. So we have covered so far these solutions, but definitely I need to revisit these solutions, especially the one I stuck. Even this one is hard, they are saying, but I need to solve it without help, but need to practice more, so get the idea to handle corner cases, right? Okay, so so it's 143, and let's close it. So we have covered all the problems, and that's great. So we made today we just made pretty much great progress, and yeah, so that's all for today, and we'll see you tomorrow. And yeah, I can't close it from here. I just have a habit of, like, whenever I'm just you can say whenever I'm just stopping the camera, I feel like I just have to close it from here, because most of the time when I'm recording something, but here I'm just streaming, so I do not need to stream close from there. First I need to close it from the stream part, and here I will just finish it. So thank you so much, bye bye, and good night, and wish you the best.